Alright guys, we're looking at difference of two squares method. So this works when we have two squares, 1, 2, and we have a difference, subtract. It does not work if there's an addition here. So first thing is you can only use this method, two terms, subtract between. Okay, first thing is we want to make each thing look like a square. So x squared already looks like a square. 25, we know that 25 is 5 squared. So if we can put it in the form of something squared take something else squared, we can really easily factorize it into two brackets. Okay, the first term, or the first square, right, is going to be the first term in each. The second square is going to be the second term in each. And all we need to do is have an addition and a subtraction. And I've now gone from an expression with two terms to two factors. In my next example, I need to factorize 9x squared subtract 100. Now, again, I'm looking at it and I'm recognising some squares. I'm recognising 9, I'm recognising 100, and I'm thinking, oh, they look like squares. But at the moment, it doesn't look like something squared takes something squared. So I have to make it look like that. So 9x squared, well, I know the square root of 9 is 3, and x squared is there. So if I think about my indices rules in reverse, 3x squared, all squared, the square would affect the 3 and make the 9, the square would affect the x, would make x squared. So that's okay. And 100, we know that that is 10 squared. Now you might like to use these brackets so that you've got two really clear terms. Difference of square rule will always end up with two brackets. First square, first term. Second square, second term. Plus in one, subtract in the other. And it doesn't matter which way around it is. 9x squared take 100 equals 3x plus 10, bracket 3x subtract 10, and they're my two factors. My last example might not appear to be a difference of two squares at first glance. So 2x squared subtract 32. Now looking at that, I know 32 is not a square number straight up, okay? And I know that 2 isn't a square number. So originally I might think, oh, that doesn't do anything. Always look to see if there's a common factor. Because if we can take out a common factor, it can make other methods possible. So let's have a go. Let's take out 2. And that would leave me with x squared subtract 16. Now when I look at that, that looks much more promising. So keep this 2 out the front. That's one of the factors. And let's just work on this bit that's in the bracket at the moment. Okay, so x squared subtract 16 is the same as x squared subtract 4 squared. Okay, and by our difference of two square rules, we're going to end up with two brackets. X will be in the beginning of both brackets. 4 will be in the end of both brackets. And we're going to have a plus and we're going to have a subtract. So in this case, we took out a common factor of 2, okay, which gave us a smaller expression, and then we were able to use the difference of two squares to find the other two factors. Now what I'd like you to do is go into exercise 7.4 and have a go at questions 3 and questions 4, as many as you can do in about 15 minutes. Thanks.